part 2, we're going to take a look at a review question. It's 2 minus 3 cosine of theta. Notice A is less than B, so this means it's going to be our looped lemma. So we're going to make a table, just like we did yesterday. Theta, R, and we're going to pick numbers that are for cosine that are nice for cosine. These are our pi over 3's. So first one, 0. Next one, pi over 3, pi over 2, 2 pi over 3. Notice we're always going to use the quadrantals, but pick nice ones as well. Pi over 3's. So we get pi, theta, and r. Keep going around the circle. 4 pi over 3, 3 pi over 2. Remember, it's always very nice to have your trig values memorized, right, Katie? And we go 2 pi. Now, plugging these values in, we get 2 minus 3. What's the cosine of 0? Nobody answers it. 1. So we get negative 1. So when we're facing 0, we're actually going to start with a loop. We go backwards 1 unit. We go 2 minus 3. Now the cosine of pi over 3 is 1/2. Be very careful. That's 2 minus 1/2, and that gives us a positive 1/2 right here. So as I'm facing pi over 3, we go up half a unit. Now, it seems kind of weird, but you actually have to go through the origin and then go up. So that's our start. Do pi over 2, 2 minus 3. The cosine of pi over 2 is 0. So when we're facing pi over 2, we actually go up 2 units. And it's going to kind of continue going up like so. Not going to be perfect, but it's okay as long as you get the idea. 2 pi over 3, 2 minus 3. Now the cosine of 2 pi over 3 is negative 1/2. Be careful, 2 negatives make a positive, and that's going to put us at 3.5. So when I'm facing 2 pi over 3, we have to go out 1, 2, 3.5 points. 3.5 radii. Plug in pi, 2 minus 3. The cosine of pi, negative 1, and that gives us a distance of 5. So when I'm facing pi, we go out 5 from the center. 1, 2, 3, 4, 5. And there's our graph so far. So far it looks pretty good. Plug in 4 pi over 3, 2 minus 3. Again, 4 pi over 3 gives us negative 1/2, which becomes, again, 3.5. If you need to, slow it down, pause if you need to, just to check those. So when I'm facing 4 pi over 3, 1, 2, 3, then there's our point. And I keep going. 3 pi over 2, 2 minus 3. Now the cosine of 3 pi over 2 is 0. So that puts us at 2. 1, 2. And there's our graph. Keep it going. 5 pi over 3, 2 minus 3. Now the cosine of 5 pi over 3 is a positive 1/2. So be careful with that one. And we get, again, 1/2 here. So at 5 pi over 3, we're at 1/2. I keep it going. And if I plug in 2 pi, no sense reinventing the wheel. That's going to put us back at negative 1. And you're going to complete the inner loop. And there's our loop right here. Okay? So let's take a look at one more kind of funky one that we're not going to necessarily have you do in class, but it's kind of a cool little one right here. It's called a lemniscate. Okay, now a lemniscate is sometimes what we call a propeller. And I'm just going to show you this one because we're going to see it in calculus next year anyways. It says r squared equals 2 cosine 2 theta. Now, kind of like our rows, so we're going to pick anything divisible by 2. Nice ones, of course. Theta and r. 0, pi over 4, pi over 2, let's keep going, 3 pi over 4, pi, 5 pi over 4. Now next year in calculus, I'm actually going to show you kind of an easy way to do this one. 3 pi over 2, and 7 pi over 4, and 2 pi. Plug in 0. Now we're saying r squared equals 2. Well, what's the cosine of 0? But 1. So what happens here is we get plus or minus the square root of 2. Nah, I probably should have picked an either. You know what? Let's cheat. Let's make that 2 or 4, just so it looks nice and pretty for us, okay? Just so it looks pretty for us. So this becomes 4, and the cosine of 0 is 1. So we get plus or minus 2. So when at 0, my radius says I go out 2 in both directions. Plug in pi over 4. R squared equals, this becomes in the cosine of pi over 2, which is 0. Which becomes, of course, 0. So what happens is that pi over 4, here's pi over 4, I'm back at 0. So it's going to go 0 right here. But also it's plus or minus 0. So this also goes to 0 as well. Plug in pi over 2. Watch when we plug pi over 2, we get r squared equals 4. The cosine of pi over 2 becomes cosine of pi, which is negative 1. So I get r squared equals negative 4. Well, what's the problem? You can't take the square root, so it does not exist. Matter of fact, same thing for if I plug in 3 pi over 4, that's again going to give me 0. Plug in pi, the cosine of 2 pi, here's where we get our answer again. We get r squared equals 4 cosine of 2 pi is 1. So we get plus or minus 2. So if you notice, at pi, we're back to where we started. So all we're going to do is we're going to complete it. It actually kind of goes like so. And this is what we call a lemniscate. Now, this is basically, if you think about it, if r would equal 4 cosine of 2 theta, we would get a rose. Well, here we're still a rose, but because of square, and since any of the negatives won't work, we don't have to worry about the negatives. So we only get half the number of petals. And there's our graph. So down below here is a little shortcut for it all, if you notice. Cosine, sine. If n is odd, that's the number of petals. If n is even, we get twice the number of petals. Orientation, cosine is on the x-axis, or the first petal is normally in the first quadrant. So we'll take a look at more of these tomorrow and get some practice. Don't forget our quiz. No, we don't have a quiz. We have a quiz. Oh, yeah, we do have a quiz tomorrow. Study for it. Bye.